The first portion of today's lecture is the classification of the matter. So this is the only the chart we are going to discuss today, and let's start with the matter again. And you remember in the previous lecture we studied the different states of matter, and particularly the solid, liquid, and the gas. But now today we are going to discuss the classification of the matter. How can you classify the matter into the different all these components? And at the end we will do some exercise, and the objective is, if I give you any of the compound or the molecules or whatever we are going to discuss over here in today's lecture, then you can identify whether these are the elements, compound, solution, colloid, uh, even the mixture. So these are the terms based on you have to identify your particular matter. And let's first listen carefully actually on what are the main important things to differentiate the different matters, and these are called the classification of the matter. So you remember the matter is particularly that anything that uh, takes up the space and has a mass, it is called the matter. So the first classification is we are going to divide this matter, of course, this mass and this space, which is anything which is occupying this space and has the mass. The first classification is we are going to divide into the two parts. One is the pure, and other one is the mixture. So you remember pure substances which is present in the pure form and not having any other component over there. That's why these are called the pure substance. We will further classify into element and the compound, and then we will see what are the pure compounds. So the first is I'm going to differentiate between the pure and the mixture. So the mixture is the any physical combination of two or more substance. That means this is the pure substance. When two substance, pure substance are going to meet together, they form the mixtures. So that is the difference between pure substance and the mixture. So this is the first classification, the matter which is divided into the pure substance and the mixture. So actually these are the terms you are going to use further clarify the your matter. And pure substance is divided into the element and the compound. That means compound may also be a pure, and the element may also be a pure. So this is the general terms, but the important term is over here is the element and the compound, because both are the pure substance. So if I say the matter, what is the element? Element is the pure substance, and it is also the form of the matter. Compound is also a pure substance, and it is also a form of the matter. So now what is the difference between element and the compound? Again, this is again very simple classification, and we have you have already learned the definition of the element in the previous lecture. That means this element cannot be further decomposed, and it is represented by a specific symbol in the periodic table. Let's suppose it is the hydrogen, carbon, nitrogen, iron. All these are the element. So these you can easily identify with their symbols. If they are present within symbols as mentioned in the periodic table, these are called the elements. So elements are the pure substance, and these are also form of the matter. So again, if you want to differentiate between the element and the compound, and the compound is the chemical combination of two or more elements. It is very easy to understand. In a similar way, as the mixture is the physical combination of two or more substance, pure substance, it is called the mixture. And in a similar way, it is the chemical combination of two or more elements, it will form a compound. And these are the few of the examples are given over here. Let's suppose it is the water. Water is having the two elements, one is the hydrogen, another one is the oxygen. So if it is the hydrogen, it is the element in the pure form. If the oxygen alone, it is the element. But when these two elements are joined together, these will form the compounds, and the compound over here is the water. Another example is this is the calcium carbonate, CaCO2, carbon dioxide, or it may be a calcium carbonate, CaCO3. Okay, so it doesn't matter what is the actually the composition over here. So we are going to differentiate whether this is the element or the compound. So this is the pure compound because this is the only compound. This is the whole one compound. This is the whole one compound. So why we call it a compound? Because it is the chemical combination of more than two elements. So this is the calcium, it is a one element. This is the carbon, this is the second element. This is the oxygen, this is the third element. So this compound is composed by the combination of three elements, and that's why this is called the compound. So again, very simple differentiation. One part we have finished. One is the matter is divided into the pure substance, and there are two form of the pure substance. One is the element and one is the compound. In the periodic table, if it is the pure symbol, then it is called the element. And if it is a combination of more than Faizan, I am coming to you. I will take the question. Just first finish this slide. So later on, you all of you can take a note during the lecture, and I will ask. I will take your questions just at the end. So first, let's have a to finish this slide. Okay. So this we have finished over here. Sorry. Okay, the second is the matter is the mixture. So that means the physical combination of more than one substance, it form a mixture. So the mixture in a similar way, you have divided the pure substance into element and the compound. The mixtures are divided into the two forms. One is the homogeneous mixture, and other one is the heterogeneous mixture. So the first, let's finish this one. What is the homogeneous mixture? It is having the same appearance throughout, or it is having in this single phase. That means if it is a solid or liquid or gas. So solid is the one phase, or liquid is the one phase, or the gas is the one phase. If your matter mixture of more than two substances present in a single state, that means these two substances are in the solid or in the liquid or in the gaseous states, then this type of the mixture is called the homogeneous mixture. So contrary to this one, the heterogeneous mixture, the components can be distinguished. That means it may be not uniform appearance as compared to the homogeneous mixture. So possibly more than one phase of the state of matter is present. That means solid and liquid, or gas and liquid, or solid and gas. So these are the combination of more than one phase. If they are present, then it is called the heterogeneous mixture. And even within the classification of heterogeneous mixture, because this is at a first instance, we are going to differentiate between these two. Even the solids alone may be called a heterogeneous, liquids alone may be called a heterogeneous. But here important is over here is as a physical appearance, sorry, if you are not going to differentiate between the different substances within the state, that means your mixture is called the homogeneous. And if you can the components, if you can differentiate, that means the components can be distinguished, then this is called the heterogeneous mixture. So because you will learn clearly with the proper definition over here. So again, we are going to differentiate, or we are going to divide the homogeneous mixture into the two parts. One is called the solution and other one is called the colloid. So solution is composed of solute and the solvent. And in chemistry, we have the two components. One is the solute, other one is the solvent. That means let's suppose I'm giving you the one of the very simple example. If you prepare let's suppose the syrup at home with the combination of glucose or sugar in water. So when you put some sugar in water, sugar is the solute and your solvent is the water. So when you put this sugar into the water, so it form a solution. So that means this type of the mixture is called the homogeneous mixture. So why it is called the solution? Now look at the definition of the homogeneous mixture. Why solutions are the homogeneous? Because when you put the sugar into the water, it dissolve, and after the dissolution you cannot differentiate between the sugar and the water, so you will find a single state over there. So this form of the state is called the homogeneous mixture. So the solution is one form of the homogeneous mixture, and mixture of course is it is the coming from the matter. So look at the collide. Collide, now the difference all these four is just based on the particle size. If the particle uh, is becoming bigger, then it will convert into the collide. So the particle, that means the particles do not settle out throughout the time, or you cannot see the particles with eyes. So, but these are very thick or sticky as compared to the solution. So one example, let's suppose it will be clear from the examples. The one example of the collide is the milk. So again, milk is the mix. It is the mixture because it is having a proteins, or having a different metal ions, also the water. So you cannot differentiate between the metal ions, water, or proteins in the milk. That's why this is called the homogeneous mixture. But it is called the colloid because here again, how can you differentiate between the solution and the colloid? Again, remember the example which I have given to you for the formation of the sugar syrup. That means when you put the sugar, your glucose or the sugar into water, so compare these two solution, milk with the syrup. So what is the difference between these two? This is the transparent, and this is the actually it is semi-transparent. It is not going to be transparent. So this is one of the physical appearance on based on which I am giving you the differentiation between the solution and the colloid. So if you can see outside the solution, outside what you have prepared, then it is called the solution. Otherwise, it will be a collide. Another example is the fog. So when you see the fog in the morning, so this is the one form of the collide as well, because this is a mixture of a lot of pollutions, or carbon dioxide, or different gases. So, but you will find in a cloudy way, it is you cannot differentiate all these components in the fog, and this is called the collide. But this is also somehow it is the semi transparent. It is not very clear, you cannot see easily outside the fog. That's why when there is the zero visibility, you can not see outside the your even 1 meter, or whatever it is the distance. So that's why the fog or milk are considered under the heading of the collide. So other example now, the heterogeneous mixture are also divided into the two. One is the heterogeneous, that means totally opposite. There are, if you put some let's suppose the oil into the water or some stone into the water, so these two phases you can easily differentiate. So when you can easily differentiate, that means it is the heterogeneous. It is the heterogeneous, it is the heterogeneous. So it will remain the heterogeneous. So there is no any other appropriate term. So to further classify this heterogeneous, we will call them the heterogeneous. But this is the intermediate between colloid and the heterogeneous. So further, if the your solution or your the mixture is completely opaque, that means now the particle size is bigger than the colloid, then it is called the suspension. And one of the example is the blood. So let's here we have discussed the example. One example is the formation of solution by using the sugar and this water. This in this we consider the example of fog and the milk, and now you can consider the example of the blood. So blood is thicker, it is completely opaque. That means it is going to be settled down with the gravity, and that means this is the one of the form of the suspension. So if you differentiate between all these different type of the mixture, so one is the solution, the particle size is less than 1 nanometer, and if the particle size is 1 to 100 nanometer, this is called the colloid, and the suspension is it is greater than 100 nanometer. So these particle size you cannot see by your naked eyes. Here this is the only, if I ask in the examination, this is one of the criteria you can differentiate between the solution, colloid, and the suspension. And otherwise, in a simple way, as I have described, you can easily look at if it is totally transparent, and that it will be a solution. If it is opaque, then it will be a suspension. And if it is intermediate between these two, it will be a colloid. And if it is the two states are opposite to each other, that means the component can be distinguished easily by your naked eyes. Like I have give you the example, I have given you the example. If you put some stones in water, you can easily differentiate where is the water and how much stone or how many stones are there in the water. So this type of the mixture is called the heterogeneous mixture. So I will coming back to this slide again to do some sort of the exercise, and I will engage all of you so you will better learn these concepts. So let me finish with some more examples. So these are the again the matter, the pure substance element. Some elements are given over here. This is the lead, sodium, zinc, cobalt. All these are the element, and these are the pure substance. Again, compounds, it is a carbon dioxide, water, silicon dioxide, sodium chloride, sugar. All these are the compound there because it is composed of the different combination of the elements. Again, mixture, it is a homogeneous or the heterogeneous. Again, one heterogeneous is missed over here because it is the same terminology we are going to use. Otherwise, these are the main types. So one is the solution, and this is a colloid. This is the one of the drink, tea, air, soda, brass. It is the copper and zinc alloy. Okay, so this is called the solution. So when you prepare the uh, tea or the air or having some soda, okay, syrup, you cannot differentiate, and this all these are the transparent, and these are called the solution. And homogeneous, there is, if it is thicker than this one, and some example, more examples are given over here: paint, milk, foam, and honey. These are examples of the colloid, and these are the suspension. This is a trail mix. This is similar to the you use the shahi meva or the nas, pan masala, like somehow. That means the combination of different dry fruits, blood, water, and oil. I have given you the example. It is a pavement, that means pedestrian pathway, where you will find a different combination of the tiles or there, and spaghettis sauce. All these are the some of the examples of the suspension.